If you want infinite network scalability, it's not a miracle you need. Take your business to a better place. Virgin Media Business.
The incandescent light bulb. Unchanged for 200 years, it gives off a nice glow, but it wastes energy and money. There are other options. The CFL and the LED are both more efficient, but neither is quite as pleasing to the eye. Now, a handful of companies are working with a nanomaterial that has an intriguing property: luminescence. This liquid is full of quantum dots, tiny crystals that modify the light that passes through them. When placed on top of an LED bulb, they adjust it, giving a very efficient device the warm look of incandescent. QD Vision in Watertown, Massachusetts is one of the companies using this new technology.
So we founded QD Vision, a team of 5 of us founded QD Vision in 2004 and 2005. This is QD Vision's product. We call this a quantum light optic. It's a plate of glass with the quantum dots in between, and when you hit it with incident radiation, incident light, this is a UV bulb that I've got down here, it glows, it luminesces. QD Vision solves the color quality problem with LEDs, making the color quality as if it was incandescent while maintaining LED efficiency.
But how does this help to make a better version of this? To understand, we'll have to take a brief look at the history of lighting. First, the sun. The sun emits a broad spectrum of electromagnetic radiation. Part of this spectrum, between 400 and 700 nanometers in wavelength, is what humans see as visible light. Human eyes perceive radiation with a wavelength of around 700 nanometers as red light. As the wavelength decreases, the eye, or more accurately the brain, sees yellow, green, blue, and finally violet. The mixture of all these wavelengths appears white. In an incandescent bulb, the tungsten filament also produces a wide spectrum of radiation. But because its temperature is lower than that of the sun, the mixture is different, and the resulting light does not resemble daylight. Like the sun, incandescent bulbs also produce a lot of infrared radiation, or heat. For every watt of electrical power consumed, an incandescent bulb produces only 10 units of perceived brightness, or lumens. Compact fluorescent lamps, or CFLs, work by energizing the electrons in atoms of mercury vapor to produce ultraviolet light, which is much more energetic than any of the visible sort. This excites a phosphor in the lamp, causing it to fluoresce, producing visible light. But the resulting light once again does not resemble daylight. Instead, it has strong peaks in certain parts of the spectrum. CFLs are, however, much more energy efficient than incandescent bulbs, producing 35 lumens per watt. Light-emitting diodes are semiconductor devices that can produce light by a process called electroluminescence in a range of colors. To produce white light, blue LEDs are used in conjunction with a phosphor, which emits yellow. The mixture of the blue and the yellow light results in a harsh white light. LEDs are, however, even more energy efficient than CFLs, wasting no energy as heat and producing 65 lumens per watt. They are an increasingly popular form of low-energy lighting, despite the harsh quality of their light. QD Vision is betting that it can fix this color problem by adding a layer of tiny semiconductor crystals called quantum dots. By selecting quantum dots of a precise size, blue light from an LED can be turned into a mixture of colors that more closely resembles the light from an incandescent bulb or from the sun, which is where we began. The best way to see this is to turn on the lights. You see, once we're accustomed to the look of an incandescent, the switch to LED might be a greener choice, but it seems unsavory. That's true until a layer of quantum dots make this fruit look worth eating again.
A quantum dot is a semiconductor nanocrystal. Starting with any semiconductor material, if we make it very, very small, 2 to 12 nanometers in diameter, all of a sudden we change the properties of that semiconductor drastically.
The secret is in reduction. By being incredibly small, the quantum dot confines electrons, raising their energy. The smaller the quantum dot, the more energetic it becomes, and the result is in the color.
Photon comes in, excites the quantum dot, new photon of a different color comes out.
QD vision grows quantum dots in a hot organic solution. The nanocrystals appear clear at first, but as they rapidly increase in size, the light they emit changes from yellow to red. Each different color might have a specific application, and the art is also in stopping the reaction at the right moment. Once a second coating is added, the quantum dots become more stable and fluorescent. Here, in a final stage, the smallest crystals emit blue when hit by UV light, and the largest emit red.
If you stuff a spring into a smaller box than it would like to expand, you're building up energy, potential energy in that spring, and raising the energy of that system. That's essentially what we're doing here on the quantum mechanical scale.
And this is what the final product looks like. 2 thin pieces of glass with only a milligram of quantum dots in between. When placed in front of an LED bulb, the extra blue light is converted into red, and no excess energy is lost as heat.
And so the result is that you get the color quality that was missing. All of those red hues that were missing in this light that make your skin look really ghostly and flat, we then put back in, and we don't waste light. We don't waste energy in doing it. I mean, we can touch the front surface of the bulb without burning ourselves. The resulting spectrum has the blue of the LED, it has the yellow of the phosphor. We've just augmented it with the red of the quantum dot. Quantum light optics don't replace LED lighting, they augment it. We improve LED lighting to have the spectrum that all lights want to have, should have, while maintaining the efficiency of the underlying source.
Seth Coe-Sullivan said that in a single day, enough nanocrystals can be grown to light thousands of lamps. He predicts that LEDs with quantum light optics will be hitting the shelves within months, and that in the next decade, a majority of lighting will be LED-based. If quantum dot lighting does take off as promised, the incandescent light bulb may finally be made obsolete. Not a bad run for a 200-year-old technology.
The Economist.